This lesson is going to look at yet another way of solving quadratic equations. This is going to look at completing the square. Completing the square, when you first look at it, looks kind of complicated. In order to complete the square, you have to have the constant term, or c, on its own side of the equation. So if we're looking at the equation that's given here, x squared plus 8x. In order to figure out what to add to both sides to complete the square, you have to add b over 2 squared. Our b value there is 8. So I would have to add 8 over 2 squared. 8 over 2 is 4, and 4 squared is 16. So I would have to add 16 to both sides to complete the square. So let's take a look at actually what it would look like to actually do that. So if I'm looking at the equation, x squared plus 10x equals 24. I have to figure out what I'm going to add. And remember, what you're going to add is b over 2. That doesn't look good. Okay, sorry, b over 2 squared. So in my case here, b is 10. So I'd be adding 10 over 2 squared. 10 over 2 is 5, and 5 squared is 25. So I would be adding 25 to both sides. So I would have my original parts of my equation, x squared plus 10x, and then I'm going to add 25 to it. And then on the other side of my equal sign, I have 24, and I'm also going to add 25 to it, because remember, the property of equality tells you if you add something to one side, you have to add the same thing to the other side in order to keep it equal. So what I want to do now is I want to factor, is that I want to simplify the right-hand side. So if I simplify the right-hand side, everything on the left would stay the same. So I would have x squared plus 10x plus 25. And then if I simplified the right-hand side, I'd be left with 24 plus 25, which would give me 49. So now I want to look at factoring this left-hand side. If I factor this, that should be a perfect square. So I'm going to have it be x plus something squared is equal to 49. Now, where you figure out what that something is, basically what you're putting in here is the number that you squared to get what you added into the original equation. So we squared 5, so it's going to be x plus 5 squared. Now, in order to solve x plus 5 squared equals 49, I have to use the square root method by taking the square root of both sides. So I would want to take the square root of x plus 5 squared, and then I would also want to take the square root of 49. The square root and the square, just like before, cancel each other out, so I'm left with x plus 5, and then the square root of 49 is plus or minus 7. So I can then now take my equation and separate them. I could say that x plus 5 equals positive 7, and I could also say that x minus 5 equals, or x plus 5 equals negative 7. So to solve both these equations, I would subtract 5 from both sides. So 5 minus 5 cancels out in both equations. I'm left with x, and then 7 minus 5 is 2. I'm left with x here, and then negative 7 minus negative 5 gives me negative 12. So my solutions to this quadratic equation is that x is equal to negative 5 and x equals negative 12. So let's take one more example of completing the square. In order to complete the square, it's worth noting that your coefficient of x squared has to be 1. If it's anything else, you have to get rid of it first. But to look at this one that we're looking at, x squared minus x minus 3, and the coefficient of x squared is 1, so the only other thing we have to worry about is getting the constant term on the other side. So to do that, we would have to add 3 to both sides. they would cancel each other out. So I'm left with the quadratic equation x squared minus x equals 3. Now I have to begin looking at what I want to add to both sides to make it completing the square. So remember, we complete the square, it's b over 2 squared. So my value of b is -1, so it's -1 over 2 squared. So a negative squared is a positive, and 1/2 squared then is 1/4. So I'm adding 1/4 to both sides. So I'm going to say x squared minus x plus 1/4 equals 3 plus 1/4. So I want to simplify. So I have x squared minus x plus 1/4. And then I'm going to make this not a mixed number, I'm going to make it an improper fraction. So if I make my 3 into an improper fraction with 4 as my denominator, I would have 12/4 plus 1/4, which would give me 13/4. So now I can factor. So I would have x minus, because this tells me that both signs are the same, this tells me they're both minus, so minus, and it's minus what I squared, so I squared 1/2 to get the 1/4, so it would be x minus 1/2 squared, and then that's equal to 13/4. Now in order to solve this, I'd have to take the square root of both sides. So I'd have the square root of x minus 1/2 squared and the square root of 13/4. Now if I slide my screen up a little bit, okay, so remember the square root and the square cancel each other out, so I'm left with x minus 1/2, and then if I'm doing the square root of 13/4, remember with the quotient property, we can take the square root of the numerator and the square root of the denominator. So if I'm just looking at the square root of 13 over the square root of 4, 13 I can't simplify, so square root of 13, but the square root of 4 is 2. So I'm looking at this being equal to the square root of 13 over 2. And then it's both the positive and the negative version. So now I can separate each equation and I can solve for what we have going on. So I have x minus 1/2 being equal to plus or minus the square root of 13 over 2. So in order for me to solve what x equals, I would have to solve this by adding 1/2 to both sides. So I would have x equals 1/2 plus or minus the square root of 13 over 2. Since I don't know what the square root of 13 is, and since they're both over 2, I could simplify my final answer to say that x is equal to 1 plus or minus the square root of 13 over 2. That one's, again, a little bit more complicated because the roots of that quadratic equation would not be a nice, perfect whole number.